Welcome to Emtron Training Part 8. In this training tutorial, we're going to be taking a look at setting up our basic analog inputs. These are things like our throttle position sensors, our map pressure sensor, intake air temperature, and engine coolant temp. We need to make sure that these all have been accounted for and are calibrated right so the engine is going to perform as expected. Let's jump in so we can check out how to set up our basic analog inputs. Okay, so let's get started. We're going to be taking a look at setting up our basic sensor inputs into our Emtron. These are going to be things like our map pressure sensor, throttle position sensor, engine coolant temperature, and inlet air temperature sensors. We need to make sure these basic sensor inputs are configured and calibrated properly so that we have proper sensor channel readings so that if we're applying our fuel or spark timing to the engine, it's going to be tracking as we'd expect, and we'll find that our calibration process is going to do exactly what we want. Now, if we have our basic sensor information here improperly calibrated, or we have maybe a bad sensor or bad wiring, we need to know how to spot that and what to look for in terms of the sensor channel readings. We can find the basic sensor channel readings right here at the top under main dash, looking at our manifold pressure, our engine temperature, inlet air temperature, and throttle position. All of those channels are the basic 4 channels that we have coming in. And we do also have things like our battery voltage. We can see right here, Ecu Supply Voltage. This is showing us what that voltage is going to be. We don't need to do anything with this channel. That channel is simply going to register and read what the voltage is coming in. We don't have to do any actual calibration with that. So we'll find that certain channels are basic sensor inputs, but there's no actual configuration with that. So what we're going to be doing is telling the Emtron, as our sensor is sending its input in. So the sensor might be something like a throttle position sensor. This is a 0 to 5 volt sensor. So the sensor will output a certain amount of voltage, and then we need to go and calibrate it so the minimum and maximum positions in terms of voltage will be accounted for within the software, so we know the sweep range from 0 to 100% of the throttle position sensor. Looking at our map pressure sensor. Map pressure is going to be also a 0 to 5 volt sensor. We need to set our sensor calibration scale so at a particular voltage, it associates itself with a particular amount of kPa of engine vacuum or pressure registration. Now, if we're looking at something like our inlet air temperature or engine coolant temperature, those are going to be a resistance or ohm-based sensor, not a voltage-based. And we'll find as a result, the calibration scale is a little bit different, and we need to make sure we're representing the particular sensor in its unlinear fashion. So we'll find map pressure, throttle position, they're a linear scale. We just need to know a min and max voltage to be able to give the whole calibration scale for min and max pressure or throttle position. But a temperature sensor, again, is unlinear, so we'll find that the resistance or the ohms will go in and change in an unlinear manner to the temperature, and we need to go account for that again. So there's a little bit more setup in the actual temperature sensors, but we need to make sure that these are working together in unison so that when we calibrate a specific scale from a sensor supply manufacturer, so let's just say we're dealing with an AEM temp sensor, we'll go into the data sheet for the sensor and being able to take the resistance or the voltage scale that they provide, depending on what kind of data sheet you're working with, it might be a little bit different. We would input that particular amount of resistance or ohms versus the temperature into our Emtron. So when it actually shows and it's inputting that sensor output, so the voltage or the ohm or the resistance, it'll know exactly what the temperature or position or the pressure scale is going to be and apply itself within the tables, the lookup tables. So looking at this, we're going to find right now, we're in our main spark timing table. Our load axis here is based on manifold pressure. And we can see right now it's showing us where the position cursor is at when the Keon engine off status that we're sitting in here right now, so the engine's not running. It's showing us we're about 120, 140 kPa. That's actually incorrect. We should be around 100 kPa. We'll talk about that a little bit once we set up the map pressure sensor, but this is showing that I have inaccurate sensor data programmed here, or maybe my sensor's not right. Maybe something's wrong with the sensor, but either way, we need to make sure that we're accounting for that voltage to pressure lookup so that it's associating itself here in our actual axes of the table properly, so we deliver the proper fuel or spark timing to the engines. If we have any of these channels inaccurately represented, so we'll find if we didn't go in and have that conversion from ohms to temperature or voltage to movement or voltage to pressure properly set up, we'll find that the Emtron's not going to do what... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.